Hi class, and welcome back to our discussion of geologic cross-sections and constructing them. In this segment, I'm going to show you how to take our geologic data from the map and to plot it down here on this topographic profile, which represents the Earth's surface. There are several pieces of data we need to collect. Every place, for instance, that we have a geologic contact that intersects the geologic cross-section line here, 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 and here, we need to project down to this surface below. To do that, I use a ruler. So if you'll get out your ruler, which hopefully you have handy, all you're going to do is put a little line to mark that boundary. Where is it? Line there, line there. Every place we just circled gets a line, moving across, keeping my ruler vertical, doing this fairly quickly. It does not have to be, so in this case, something that is super precise for this particular exercise. Great. The next thing we want to take are rock units or names or colors. We want to put them down here as well. BC, SS, OL, IV, SH. This wide thing here is GR, which just corresponds to this section up here. Down here we have SS. Right? It's just this segment down here. And then finally BC again. Now, the final step to constructing this or plotting data along the topographic profile is to take the structural data that we have here. We're going to first project it into the cross-section line. It's best to do this with a ruler. Okay, so we're just going to line up our ruler with the strike line, project it in so that we know where to put it or know where to plot it. Projecting it in, and then this one you'll notice projects off the page, so it's not something we can actually use. Now, everywhere that strike line intersects is an important point. Here, here, and here. There's 3 points we're going to plot. So, I'm going to come down, I'm going to put a little mark, and I'm going to put a circle. Come down to the next one, slide down, little mark, I'm going to put a circle. Notice the symbols are different. This is key. You don't want to get them confused. That's why I'm making them different. One is about the position of a boundary, and the other is about a piece of boundary orientation. And now, the dip here is 40. Normally we'd have to correct for something called a parent dip, but we're not going to do that. I'm just going to take my protractor, line this guy up at the top. This is a horizontal line. Come down to this circle. I'm going to put a line through that circle that's dipping 40 degrees to the east. Okay, where's the next data? It's right here, okay, but it's projecting into this SH. Oh, did I forget to drop down? I forgot to drop down. Let's add it in. Come across, circle, okay, it's dipping 41. So if you were doing this, you could certainly just slide it across. Great. There's another one. Now here's the thing to pay attention to. This piece of data flips the other direction. 36 degrees. So now it's dipping not to the east, but to the west. And so we're going to slope that line down to the west because that's the direction that the dip direction is pointing. Or that the dip tick is pointing. We put a little line as a guide. One more in here, 31, which is well over here. Line up our protractor. Again, don't sweat the protractor too much. Boom. We're done. Okay. Now what do we have in front of us? We have a profile with the data from the map plotted along the profile. We have the geologic units or their colors or their names or their times, whatever information is given from the map, plotted above those units. And then we have the dip orientations, in this case showing us that the dip on this side of the map dips off to the east and the dip of the layers is here off to the west.